Morning friends, I'm Ajeet Manna and today we are going to continue chapter set, lesson 4, lecture number 4. Ajeet Manna here. So what is empty set? Empty set is an any set which does not contain any element. Definition is a set which does not contain any element is called empty set or void set or null set. For example, if we go to define a set in set builder form, x such that x is a natural number which is in between 1 and 2. So a is an empty set. Why? Because there is no such natural number which lies between 1 and 2. So a is an empty set. Empty set is represented by simply open bracket, or you can write it as 5, so it does not contain any element. So coming to our question, example number 2, which says that x such that x square minus 2 is equals to 0. X is a rational number. B is empty set because does not satisfy the conditions of rational number. Okay, let's see. So here we are given x square minus 2 is equals to 0. So x square is equals to positive 2. X is equals to square root of 2. So as we all know that root 2 is a irrational number. So x is not a rational number. So the set B will definitely have nothing in this. So either you can represent empty set by simply in empty brackets, or you can write B is equals to 5. Coming to example number 3, which tells us x such that x is an even prime number greater than 2. So in example number C, it is saying that even prime number greater than 2. But the only even prime number which we have is 2. So they are seeking greater than 2, so we definitely have nothing. So you just write open bracket, just an empty set. So C is an empty set. Coming to example number D, they are saying x square is equals to 4 is odd. So we are going to solve x square is equals to 4, then x is equals to square root of 4. We get x is equals to plus minus 2. Plus 2 is also even, minus 2 is also even. So these all two elements are even. But set D is saying odd number. So we have nothing. We just empty D is equals to 5. So here I have listed some empty set which do not have any elements. Coming to our next topic, which is finite and infinite sets. Okay, a finite set, an empty set, or a definite number of element. If any set having an empty set, for example, we see 4 examples of empty set. If it is empty or it is having some elements 1, 2, 3, okay, so these are called finite set. Means we can count the number of elements containing in this finite sets. What are finite sets? If we are able to count the number of elements in a set, then it is a finite set. Otherwise it is infinite. Coming to some examples, let W be a set of all weeks of a day. Okay, W, you can create a set naming all weeks of the day. So what are all weeks of the day? Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. So we can count the number of days in this week. So this is finite set. Coming to example number 2, it says that as be the set of solution of equations x square minus 16. Okay, as we will have to write the solution of this equation. So we go to solve this equations. We send negative 16 to that side, so it becomes positive. Then we send this square to that side, so it becomes square root, and square root of 16 is equals to plus minus 4. So we have two elements, plus positive 4 and negative 4. So again we can count the number of elements, so S is also a finite set. So we just saw two examples of finite set. Now coming to the third example in our case. Third example is G is a point of all, G is set of all points in a line. So we draw a line. If you are going to put few points in these lines, so there are you can put infinite points in this lines, A B C D E F G. For example, anything, there are infinite number of points in a line. So G is an infinite set. Infinite set. Why? Because we can't count the number of points in a line. That's why G is an infinite set. Coming to equal set, what is equal set? Two sets having that two set A and B are said to be equal if they have exactly same number of elements and also same elements. Okay, so we A and B are equal if they have same elements. For example, what? Suppose I say you 1, 2, 1 and 3 and B is saying 1, 2, 3. So are these set of equals? So we go to find out. 2 is here, 2 is here, 1 is here, 1 is here, 3 is here, 3 is here. So A is equals to B. The order of the elements doesn't matter, but all the elements that present in the set A should also be present in the set B. So here I already described this set are equal. Again, if I say you, there is again another example of equal set. A is a set of prime number less than 6. Okay, A is a set of prime number less than 6. So what is the prime number? Prime number is 2, 3 and 5. Okay, and what another set I say you that another set they write as P. So P is another set prime factor of 30. So you just prime factor of 30 means 30 and just factor it. 2, 15, 2, 5 and it will not go with the 2 actually. So 3, 5 and 5, 1. So again you got 2, 3 and 5. So 2, 3, 5. So you got here that 2 is also here, 2 is also here, 3 is also here, 3 is also here, 5 is here, also 5 is also here. So A is equals to P. Though two sets or two or more sets are equal if they have exactly the same elements present in them. I will going to solve some questions in front of you. So which we have to identify here which of the following sets are finite and which of the following sets are infinite. So coming to question number first, which says that x such that x is a natural number and x is minus 1 and x minus 2 is equals to 0. Okay, so first question we are going to solve. We have to how to find out whether the sets are finite or infinite? If we are going to have definite elements, definite elements means we can, if we count the number of elements present in that, then we can say that it is finite set. Okay, definite elements, or you can say that's countable element. What are infinite set? Means very large element or not countable elements. You can say it is infinite sets. Okay, So can we find the solution of this question right there? Okay, x minus 1 and x minus 2 is equals to 0. The product of two number will be 0 if a is 0 or b is 0. So we are going to solve this. X minus 1 is equals to 0 and x is equals to positive 1. If we solve this, x minus 2 is equals to 0, then x is equals to positive 2. So we can write this as 1 comma 2. Since it has only two elements and we count these two elements 1 and 2, so we say that this is a finite set. Okay, coming to question number second, which says that x is a natural number, so that x square is equals to 4. So they are saying x square is equals to 4. We send the square to that side, which becomes square root of 4, and we put 4 bring outside, so it will give 2 plus minus 2. So we write here a set b is equals to only 2, because the negative 2 is not a natural number, so we write positive 2 as our set. So again, question number 2 is also a finite set. Can you guys solve such questions right now? Are you going to understand this question? Am I not going very fast? Am I going very fast right now? Okay. We will have to access that x 2x minus 1 is equals to 0. So we send this negative 1 to that side, so it will become positive 1, and we send this to that side, so it becomes 1 by 2. So is 1 by 2 a rational, is a natural number? So no. So we got here nothing. 5. Again, you know that 5 you can count that there are 0 numbers in this, so it is a finite set. Coming to question number or example number 1, and okay, so they are saying x such that x belongs to a natural number and x is a prime number. So we solve this. So natural number, and that to prime number. So can you count the number of prime numbers in the natural number set? I name it D, and write is 2 prime number, 3 prime number, 5 prime number, 7 prime number, 11 prime number, 13 prime number, and dot 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 dot. So there you just wrote so many, you can write so many prime numbers that belongs to natural number. That's why this set D is an infinite set. Can you just got my point that I just want to tell you guys? Why this set D is an infinite set? Because you have so many number, your counting doesn't stop if you just going to write this up to there. So here we got it as an infinite set. Now we are going to solve the last question of this example, not this lecture actually. So they're saying that x is a natural number, and also it is an odd number. I'm giving it name E. Natural plus odd, 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 and your counting doesn't stop. So that's why it is an infinite set. So this is also an infinite set. Let's forget to write here SET. We are going to solve our example number 2 for this session. So they are find the pair of sets that are equal, if any, and give reasons. So we will find out of these 5 sets which of the two sets are equal. So we're going to solve this. Okay. So as they already given that 0 is an element in set A, we are going to similarly write the elements for set B, They are saying x says that x is greater than 15 and less than 5. Okay, greater than 15 and less than 5. So suppose this is a number line and here you get 15. So greater than 15 means this side, and here we have 5, less than 5 means this side. So we actually have nothing here, or you can write that B is a 5 or empty set. V is an empty set. So we have nothing in this set. Somebody will think that, sir, here we have 0 and here we have nothing, so these two sets are equal. But no, my dear students, 0 is an element of set A. So A has one element and B has no element. So they are not actually equal. Okay, coming to question number C. C is saying that x minus 5 is equals to 0. So you solve x is equals to 5. So you got 5 in this set. Coming to question number D. We are not actually solving this question, but we are just writing the, we are converting the set builder form into roster form so that we can actually identify which of the two sets are equal, or three sets are equal, or all sets are equal. How many sets are equal here? We are going to solve this question number D right now. Part D we are going to write. They say that x square is equals to 25. So x is equals to square root of 25. If we bring this 25 outside, we get positive negative 5. So we get 5 comma negative 5. So D had two elements. Till now none of the sets are equal because they all have different number of elements and also different sets. Okay, now we're going to solve this E part. E saying that an x is that x is an integral positive root of the equation. They are saying positive root. If we get any negative root out of it, we will ignore it. Okay, so we are going to solve x square and minus 2x negative of 15 is equals to 0. If they didn't write anything, we write 1 here, and we just try to multiply these two equations, these two coefficients, and we get 15. So we are going to prime factorize the 15. We get so 2 will not cancel out this. We'll write 3 here and we get 5, and 5 here we get 1. So we will have to form 2 out of 5 and 3. So not only 2, we'll have to actually find negative of 2. So I will subtract 3. I will subtract 5 from 3. Okay, so we will write x square positive 3x and negative of 5x negative of 15 is equals to 0. And if we are going to take common out of it, we will take common x. We get x plus 3. We will take common negative of 5. We will get x plus 3 is equals to 0. Then we get x plus 3 and x negative 5 is equals to 0. We get x is equals to negative of 3 and positive of 5. So these are the two roots of these equations, but they are saying that you will have to take only positive roots. So we will left this negative 3 in the door and we will put E set as positive 5. So from this conversion of set builder form into roster form, you got to know that set C and set D are actually equal. So we will write C is equals to E, and none of the other pairs are equal. We can't say that these are equal because it has two elements and it has one element, so you can't write this to be equal. Okay, you got my point? Coming to our last example of this session, that is example number 3. They are saying which of the following pairs are equal set. I mean, we have to find out that are the sets are equal, and if they are equal, then you have to justify your answer with the reason. So we are going to solve okay, the x is a set collection of all the letters of alloy. So we write A, we write L, we write O, we write Y. It has 4 elements. Now B is a set which contains the letters of this set. Okay, we write L, we write O, we write A, Y, and we write A. So they are saying is X and B are equal or not. So we will find that A is here, A is here, L is here, L is here, O is here, O is here, Y is here, Y is here, and both of them are only 4 elements. So since all the elements are same in this case, all the elements that present in set X are all present in set B. So we write X is equals to B. You can also write the reason because all elements of set X is present in set B and they have equal number of elements also. They have equal number of elements and they have all the same elements, so set X is equals to set B. Coming to our question number second of this, they are saying X is a set which n belongs to Z, means n belongs to an integer of this. Okay, so we will solve this question. N square is less than 4, n square is less, n is less than what? N is less than square root of 4, so n is less than positive negative of 2. So they are actually saying less than here, and Z belongs to what? Z belongs to, means n belongs to this number, integer actually. Okay, so we write a set here is, so what are the integers that are less than positive and negative 2? So actually they are negative, they are less than 2, negative 2. So what are the integers? We have infinite numbers of elements that are less than negative 2, negative 5, negative 4, negative 3, and negative 2 also. So these are the set of element A. Now we are going to solve the set B, as B is equals to, we will have to solve this equations. X square minus 3x plus 2 is equals to 0. Then we write so R here is a real number, X is a real number, so anything can be solved here. So we will solve here X is equals to 2, and we can make it as negative 1, negative 1x, negative 2x plus positive 2 is equals to 0. X minus 1 minus 1 minus 2x minus 1 is equals to 0. X minus 1 and x minus 2 is equals to 0. So we get here two elements in set B as 1, 2. These two sets are not equal, since it is an infinite set and it is a finite set. It has just only two elements and it has an infinite elements. Okay, so A not equal to B. So that's all for today, and we will very soon doing such amazing question in this sessions. Thank you for watching.